continuing on in lesson 4.2, so 4.2 notes 2. And in this we're going to be working with our x and y intercepts again, but we're going to interpret the meaning of them in real world problems. So it looks like we first need to open books to page 238, so I'll give you a moment to do that. And on page 238, we're going to look at the check it out problem at the bottom of the page. So in this problem, we have the situation: the school store sells pens for $2 and notebooks for $3. The equation 2x plus 3y equals 60 describes the number of pens x and the number of notebooks y. So the x value in it is representing how many pens, the y value, how many notebooks, and that equation represents how many you can buy for $60. So we are going to take our equation that's been given to us in standard form, and we're going to find the x-intercept and the y-intercept. So just as we were doing yesterday, we have, when we're looking for the x-intercept, that means we are going to put 0 in for y and solve the equation for x. So we're going to have our 2x equal to 60. 2x will get divided by 2. 60 will get divided by 2. And we will see that our x value, our x-intercept, is 30. Okay, we're not going to graph that yet. We're just going to, we'll move on here and we will find the y-intercept next. So we're going to, when it's the y-intercept we're looking for, that is when the x value is equal to 0. So we'll put 0 in for x and solve the equation for y this time. So we have 3y equal to 60, and we'll divide both sides by 3. And we will end up with y equal to 20, or in other words, our y-intercept is 20 for this situation. Okay, so let's get our coordinate plane labeled here so that we're going to be able to graph. We know that the x value are representing the number of pens, so we'll put a title of pens. You know, I'm going to use the same color that I used for finding the, so I'm going to use red. Pens. Number of pens are represented on the x-axis, and the number of notebooks are represented on the y-axis. Okay, and then the next thing we need to do is we need to decide what scale should we use, what should each grid line represent. Okay, so we know that the x-intercept is 30, so we know that we got to be able to at least get out to 30 on this, on the x-axis. So we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, about 20 grid lines. So let's go by 2's on the x-axis. So the first grid line would be 2. Of course, we have 0 here in the corner. And it's going to get kind of busy if we try to label every grid line. The next grid line would be 4, but we'll skip over it, not labeling it. And we'll say 6. The next one would be 8. We'll not label that one, but we know it's 8. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. We knew we had to at least have it out to 30. Okay, so we can put our x-intercept there. Let's get our point there. showing the x-intercept. Okay, notebooks, they're on the y-axis. We only need to get to 20. So in reality, so we don't have such a small graph, we could go by ones, because we have 20 grid lines. This looks like a square. So let's go by one, so then every other one we'll label. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and the very top one is our 20. So we're going to put a point at 20 on the y-axis on our, okay, a very good job there. When we do that, we're going to put a point at 20 on the y-axis. Okay, and then we're going to, this would be it would be a continuous graph in some sense, but in reality more a discrete graph. But we're going to connect those intercepts, and it'll appear to be continuous, even though we know we can't have parts of pens and parts of notebooks. So with your straight edge, and if you haven't gotten one yet, you can pause this and let's get them out to you. With the straight edge, we're going to draw a line segment going between the two intercepts. We aren't going to extend it into any of the other quadrants, because in quadrant 2 we would have negative amount of pens. That doesn't make sense. Down in quadrant 4, down below, we would have negative number of notebooks. That doesn't make sense. So we are going to just leave it as a line segment, and then we're going to write over here to the side of the graph where x and y are whole numbers. So remember those restrictions. So since we don't want to have to try and figure out what are just the points that we can include in our discrete graph, instead we can just leave it looking like a continuous graph and give the restriction where x and y are whole numbers, because we don't talk about parts of pens and parts of notebooks. Okay, so we have done what A said, graph the function and find its intercepts. Well, we found the intercepts to help us graph the function, right? Part B, what does each intercept represent? So in this situation, we're going to say, what does the x-intercept represent? And what is that y-intercept really representing? What is it really telling us? So the x-intercept. That represents, since it's ordered pair 30, 0, it represents the number of pens purchased when no notebooks are purchased. Or in other words, let's get this written here first. You're going to spend all of the $60. You can buy 30 pens, but you can't buy any notebooks then. So that would be the largest number of pens you can buy. And when you do that, you get the most pens you can get, then you have no money left for notebooks. Okay, let's talk about that y-intercept, which is 20. So the y-intercept, which is the y's are the number of pens. We're talking now about pens, so the number notebooks, excuse me. The y values are representing the notebooks, so the y-intercept represents the number of notebooks purchased when no pens are purchased. So the y-intercept represents the number of notebooks purchased when no pens are purchased. Or in other words, again, if you're going to spend all of the $60, you want to get the most number of notebooks that you can. The largest number of notebooks you can purchase are 20, and when you do that, you can then not purchase any pens. Okay, so when you are describing what the x and the y-intercept represents, you need to be complete in your description. Okay, let's move on then to an additional example that I have on the back side. Okay, we have Trish who can run the 200-meter dash in 25 seconds. The function f of t equals 200 minus 8t gives the distance remaining to run after t seconds. So the f of t, they're saying right here, represents distance remaining. And the t is the number of seconds, okay? So it says graph this function using the intercepts. So we have, remember, f of t equals 200, take away 8t. That's our function that represents Trish running the 200-meter dash. Remember, f of t is the same as y. So we really have here y equals 200 minus 8t. And we have two options here. We can either work with it in the form that it is to find our x and y-intercept, or we can put it in standard form. And when we put it in standard form, the x's and the y's need to be on the same side. So in this case, the t value is actually our x and the y. So we have our x is actually t. So if you want to change it to x, you can. It's not a big deal. Okay, let's add 8t to both sides to get those over there with those y's. Let's get it in standard form. Addition allows us those to have to be in any order, but it doesn't really matter if it's not exactly in the right order to be in standard form for this situation, because we are just using it to help us find the x and y intercept. Okay, so let's find the x-intercept first. So let's do the x-intercept, where we put 0 in for y and solve it for, in this case, t. So we're going to have 8t equals 200. We'll divide both sides by that 8. How many times can we take 8 out of 200? Think of it like money, maybe that'll help you be able to do without a calculator. There are 8 quarters in $2. There are 8 $25 in 200. So 25 is our t value, known as our x-intercept. Okay, let's do the y-intercept now. And when we do the y-intercept, we put 0 in for x. In this case, it's going to go in for the t, so y plus 8 times 0 equals 200. And we're going to get there pretty quickly this time. We're going to get y equals 200. Okay. Now, if you did the same thing I did, got too close to the graph, you might want to move your y-intercept work down to here, which is what I'm going to do right now really quickly. Y plus 8 times 0 equals 200. I'm going to get y equals 200. I'm going to erase so that I have room to label my coordinate plane here well. Okay, so I'm going to put labels on our t-axis, also known as our x-axis. And remember, t is representing time, so we're going to put time. And we have to put whenever it's time, we have to put what's this time measured in. When we or any other reader looks at this graph, they should be able to tell that. And it looks like I've already picked the scale for this one. I say we're going to go by 2s. So let's finish labeling across. So if every grid line is 2 and it's going to get kind of busy, I'm going to skip and not show every name. You decide what's going to work for you. 16, 24, 28. So it actually goes out to about 30 seconds, but it's kind of busy if I try to label all of them. Okay, that takes care of our x-axis. Okay, let's just go back and get our x value, our t value, our intercept. It's 25. So let's put 25. So we have 24, 26. So 25 is going to be halfway between 24 and 26. Okay, so we have to go halfway between with our t intercept, also known as our x-intercept. Okay, now let's label the y-axis. Remember, the f of t, also known as y, is the distance remaining. So that's going to be our label. We're going to say distance. And what is it labeled in? In this case, the distance is labeled in meters. Okay. Looks like the scale that was chosen for this axis, they don't have to be the same scale. This one's going to go by tens. So every grid line represents 10 meters of distance. Again, I'm going to just do every other label. Doesn't mean that the scale changes. I just don't label the 30. I don't label the 50. But you got to be careful that you don't get off, and it's right beside the grid line, so it's easy to read. So go ahead and get labeled up on your y-axis. And it looks like the very last grid line at the top should be 200. Okay, so now we're ready to graph our y-intercept of 200. So we'll put that point on the y-axis, and we will use a line segment, straight edge, to connect our intercepts. And this one actually can be continuous because we have time can be measured in parts of seconds in this case. Time and distance can be measured in parts of meters in this case. So we don't have to write any restrictions for it. So then the next thing that we're going to do is we're going to write what does each intercept represent. So let's start with the x-intercept. The x-intercept, let's put a bullet point there. The x-intercept, and we're writing a sentence now, so we're not doing any abbreviating here. The x-intercept represents the x-intercept is 25 seconds. At that place, the ordered pair is 25, 0. So that means we have 25 seconds of time. We have 0 meters of distance. So what is this telling us? Well, basically is telling us what it said in the beginning, how long it took Trish to run the race. So the time it takes Trish to finish the race, or in other words, when there's no distance left for her to run. So the x-intercept represents the time it takes Trish to finish the race. She's at the end of the race. She's at the finish line. No distance left. So it took her 25 seconds to run this dash. Well, what's the y-intercept telling us then? So the y-intercept represents remember our y's are representing distance in meters. So when we are at the y-intercept, that is ordered pair 0, 200, which means there's 0 time expired at the start and 200 meters of distance. So what does that tell us? The y-intercept then represents the total number of meters Trish has to run in the race, because it's at the start. Time is 0. So this gives us the total number of meters Trish has to run in this race. And then when we get to the other end of the line segment, the other intercept, we find out it took her, how much time it took her to run these 200 meters. In between is showing when she has a certain number of meters left, how much time did it take her to run the distance that she, how much time there was there, did it take her to run the amount of meters that she had already run and before she gets to the end of the race. Okay, so we are done with this for today. You may be doing some of the same stuff that you did in yesterday's homework, so yesterday's notes might be helpful with this also, but make sure that when you are writing out what the intercepts represent, that you are complete and you write good sentences and no abbreviating going on and capitalization and punctuation at the end. Okay, I should be seeing you tomorrow.